Hi, welcome to a series of videos in which we design and develop a modular RPG system that will be engine agnostic. We will be writing it in C++. We're going to try to leverage modern C++. We're going to try to create a system manager which allows you to load and unload dynamically RPG systems for a game. Now, why would I want to do this? This is very complicated. It's a lot of stuff to go through. And you would be right. But I think with the upcoming release of Skywind and Skyblivion and the apparent rumored Oblivion remake, I thought it would be very beneficial to design something like this and release it, so that way somebody who wanted to build something like that could. I think that would be extraordinarily beneficial to not only myself in the future or to somebody else, but yeah, that's kind of why. What will I be using to accomplish this? Well, obviously, like I said, we'll be using C++. We will be using Flax engine. The code that we write will exist within a plugin for Flax. We will try to make it as engine agnostic as possible, basically being pure C++ without any calls to engine specifics. We'll let the Flax plugin itself deal with those engine specific implementation details if there are any. Yeah, that's about it. We're going to use Flax. I think it's a very interesting engine. There's quite a bit of the engine, it's kind of perfect, if you will, for a tutorial series, in that nobody really talks about it, nobody even knows about it, and it would be beneficial to kind of give some tutorials out in the world for this. We're going to kind of look at this. So if I went to here, you can kind of see, I pop this image right here, you can kind of see the image of the engine, and it looks a lot like Unreal in the not only the rendering sense, but also the aesthetic choices. The editor, for example, is extraordinarily Unreal-like, so it'll be easy for me to leave Unreal and use this. Many of you know I've worked on Unreal since the closed beta. I'm a engine contributor, so I mean I've been using Unreal since before it was released to the public. So you might wonder to yourself, well, why would you leave Unreal and use something new? And fact of the matter is Unreal is bloated and slow. Now, some of you might disagree. Oh, it runs fine on my machine. Well, on mine it does not. It is very slow. Compiling anything is tedious. I started making this video series in Unreal and decided that I would not, because I was just tired of Unreal. And trying this engine out, I found it very refreshing. It was very familiar because of the choices they made, but also it was just refreshing to use because the code compilation and editor performance were just there. They did what I want, so it was really nice to use this. So yeah. Now, what can you expect with this video series? Well, ideally we will have at the end of it a fully featured RPG system that has a systems manager that allows you to dynamically load and unload different systems at will. There will probably be 3D models included. I've been building some foliage. At the moment, I've got a couple plants. I've got some measurement tools. Basically, I'll be making models and using public domain textures or images to create textures, so that way we can have something to use within the tutorial series. Because without models, it will be very text-based, and I thought it would be better to have something a little more visual. So for example, like the night and day and weather and the time system, right? The weather and time. To show those, I thought it would be really cool to have something like plants. Like, for example, some flowers, they close up at night, and in the morning they start to open up, and at the midday they're, fully open, and as it gets closer to night they start to close up. I thought that would be kind of a lot better than just having text being like, oh, it's X o'clock, right? So that's kind of what you can expect. You can expect some 3D models, some textures, the code obviously, and we'll basically have everything you need to make a game. So without further ado, we can kind of jump into it. Like I said, this first video is just going to be kind of like an intro to the series and what we're going to do and accomplish and stuff like that. But I figured, you don't want to be left out with nothing. So I kind of just wanted to scroll through some of my pseudocode that I've written already that kind of goes over a lot of what the core of this is. There's a lot of template stuff. We're gonna try to, develop something that, like, basically our own plugin manager. So we're gonna have this linen plugin, which since we're using Flax, I thought it would be apt to name our plugin manager linen, because linen is generally made from flax. So I thought it was kind of funny. Yeah, my humor is very bad. So yeah, we're gonna create this linen plugin, and you might wonder to yourself, well, Flax has a plugin system. Why wouldn't you just create all the systems in their own plugin and use their own plugin manager? And that's a good point. You could do that, but since we're trying to create this as engine agnostic as possible, I did not want you have to, if you weren't going to use Flax, you're going to use something else, I didn't want to have you go through all the different files and have to remove all the extraneous Flax stuff. So by making the Flax plugin the top level thing and then implementing our own systems manager underneath it, this allows you to just kind of throw away the engine specifics one time, and it'll be very beneficial that way for you if you don't want to use Flax, for example. Now, as I scroll through some of this code, you probably see bugs and whatnot, and yeah, that's probably true. I had never compiled this. It's all pseudocode that I just kind of have in my head that I needed to get down on paper, or, well, in text editor, to kind of collect my thoughts and design the system before we actually implement it, because I work better when I can design something and then implement it. I think this is actually something that programmers, well, I'll say new programmers don't do as much as older programmers. I've been programming since the late 90s, and so I started off on a Commodore 64 writing BASIC and assembly for the 6502. So you really kind of had to think about the problem before you went and wrote assembly code. And then when I moved over to x86 and I started writing x86 assembly, you really needed to think about problems before you just went off and wrote assembly code. So I think a lot of new programmers don't design things before they program them. They just kind of program them, which, I mean, Yeah, you can, and I just think it causes more work. It's like, okay, yeah, like I did write all this, and yeah, you could call it programming, but really, it's like just pseudocode. I'm sure some of it compiles. I'm sure, I probably all of it compiles, or as close to compilation as possible. Um, but yeah, so you could see some of this stuff is like quest system. Like, oh wow, you've implemented the quest system already, and kind of. I tried to design some stuff beforehand to kind of guide the future and to guide the creation of things. So, what are some of the design goals and features that I have set up through our pseudocode so far? Well, I have tried to design the system with an emphasis on modularity, extensibility, and clean interactions between components. We want the RPG systems to operate independently of one another and that they can be loaded and unloaded dynamically. For example, a mount system might not need to be ran all the time. Like maybe the first half of the game or first quarter of the game, you don't have a mount. So why would you be running the mount system when you don't have a mount? So you don't need to be running the mount system. Or maybe you do need to be running it because the NPCs are using it. That kind of thing. So to be able to pick and choose what we're running, we can create a more performant system. And allow the picking and choosing of what systems you want to use in your own game. We're going to try to declare our dependencies on other systems. Basically, the systems themselves will declare dependencies on other systems. So that way we can get a proper initialization order of each system. So maybe this one system has interacts with a bunch of them, but interacts with a bunch of them in a certain way. So we want to be able to have a proper initialization order of our sub RPG systems. The event-driven communication is probably my favorite part about this. Essentially, each system is going to communicate primarily through this event system rather than having direct references to one another. This maintains loose coupling between the systems, so that way you can, in fact, pick and choose what you want, and it will be easy as possible. You won't really have to delete much or any code. I tried to include thread safety. As games get more complex, leaving as much performance on the table available to the game to render stuff is paramount. And so having a threaded implementation or having thread safe implementation is really good practice to ensure that our RPG system isn't too complex or too resource intensive, because we're dealing with a lot of systems that are probably going to be publishing events a lot. You can run into things that performance issues that might affect it on some systems versus other systems. So we'll try to target a low system requirements for this RPG system. I have yet to decide whether or not I actually want to do binary serialization. I might just use JSON save files so that way we can edit them. That will be useful for testing. Maybe in the future, one of the future videos, we can convert the binary serialization, or convert from the JSON files to binary save files. Not that JSON is very like it doesn't, like a JSON file is just text, right? So not that saying that those JSON files will be large, but with all the different systems and as you progress through a game, those JSON files can become actually quite large. So having a binary implementation might that might be very useful. So let's go to the system organization. How have I organized this? Well, I have some fundamental gameplay mechanics like character progression, quest, dialogue, time, save, and load. Those are like your core systems. Like what would this be if it was like a linear game without emergent gameplay stuff? So like basically your most basic RPG. So you have your character progression, you'll have quests, you'll be talking to people, time will progress, saving and loading, all of that. And each of these other systems are going to be in their own category. So weather, market, economy, world progression, that is its own phase of the development, if you will. Social and NPC interaction systems. So we're just kind of building up more layers on top of dialogue, essentially. And we have gameplay enhancements and additional systems that we'll look into. So getting to the technical part of this, we're going to try to use a lot of templates in this that have type-safe access to systems. This is very useful for trying to find compile time errors, or outright just stopping compile time errors. We're going to try to be using smart pointers consistently throughout it. It kind of allows for automatic resource management. We're going to be using an event system, so we'll have a prioritized event system with filtering. So we can have an event be issued. So for example, the quest system might send an event out, and the character progression will listen for that event, and we can tell the event system what priority is this event and if we want to filter it or not. So that's really useful. We're going to try to topologically sort our systems to ensure that their initialization is correct. Their initialization order is correct based on dependencies. So some systems will interact with other systems, and so those will need to be loaded in a specific order. One of the key strengths of this system is that we are using an event-driven communication. So, like I said before, we're going to have these events that get published and others listen for. So, for example, we have this quest completed event. Well, this quest system is going to publish this event on the event bus, event system, whatever you want to call it, and then our character progression system is going to subscribe to that event, and we're going to do something based on whether or not that event happened. So, for example, a quest might give you experience points, and we want our character progression system to listen for that event to do something about it. I have included in the systems interactions file, there is a comprehensive matrix showing how each system interacts with the others, making the architecture easier to understand and to maintain. There's some errors in it, like the save and load doesn't have a reference to the character progression and vice versa. So there are some errors in it, and I haven't gotten around to fixing it, but we can do that in due time. The whole idea behind this entire thing was to have emergent gameplay. We want everything to affect everything else, or well, not everything, but some systems should affect other systems, right? So weather can affect NPC behavior, and that might affect the economy, which affects quest availability. So the weather will not only just affect the rendering of things, but we can affect how the NPCs go about their day. We can affect the economy because some trade route got washed out and they can't get supplies to this city, and that city's got an increase in cost because they don't have a limited supply, and so and maybe the limited supply causes quest availability issues, or maybe there's a quest that gets brought up because we're running low on this thing. Can you be the guy that runs through the rain and delivers this for us? That kind of thing. That was my thought from the beginning. How could we create a Morrowind-like RPG experience with the addition of something like an Oblivion Radiant AI? That is the entire goal of this. If we can accomplish that, I will be so happy, because I love games where things happen that they didn't program. The best experiences in a game are emergent. They were never pre-scripted. Those are the best. If you ask anybody who's played any game where there's some emergent event that happens that the developers didn't exactly plan for, or maybe they planned for it but it just sort of happened through emergent gameplay, developers and players alike will tell you that those are the coolest times in a game. At least for me, I really enjoy emergent gameplay. It's just so fascinating that you can have these systems interact with in ways that you really didn't account for, and it just makes the whole game experience much richer and exciting. So what are the design strengths of this modular RPG system? Well, I'll ignore the binary serialization because I think I covered that before. The thread safety is kind of like really important here because we want our systems to be fast and not hamper rendering in any way, shape, or form. Type safety, since we're using the C++ type system, we're going to try to use the type system correctly to prevent errors at compile time. Runtime errors are annoying. We don't want those. So if we can ensure that there's type safety, we can lessen the runtime errors. That's a strength I desire. Dependency resolution. The automatic calculation and initialization and shutdown order of systems is really desirable. We want to be able to load and unload systems dynamically, not just so that you can choose what systems you might want for your game, but so that way we can reduce the load on the system as much as possible. But I think the most strong design choice is event filtering. The fact that we can filter subscriptions, so back to this character thing, the character progression system is subscribing to that quest completed event. Since we can filter these, we can do targeted event handling. I think this is like a very huge design strength that will pay itself in dividends. So a lot of these are about performance and robustness, and so I think those are the design strengths. You might see some other strengths that I have neglected to see myself. So what are some of the design patterns in Linen? Well, to be quite honest, there are a lot. I'm not going to go over all of them, but just know that I have really tried to use extensive design patterns that kind of demonstrate that Linen is following established software engineering principles, so that way we can create a maintainable, extensible, and robust RPG system. We really want our code to be as maintainable and extensible as possible. Those two things are paramount for such a complex a system of system interactions. You have all these different systems and they need to interact with certain ways. So the more we can take advantage of certain design patterns, the better. So, like I said, I'm not going to go through all of them, but we have some creational patterns. So systems get created, and there's a registration process in the Linen plugin itself. I don't know if I talked about this before, but basically the Linen plugin is the Flax plugin, and it's going to register like essentially pure C++. So that way we can create a Flax engine plugin that is using this pure C++ implementations of our RPG systems. That way we can use a different engine if you wanted to. We are using the singleton on the event bus. I think it's actually called the event system, not the event bus, but whatever, whichever way you want to think about it, it's fine. We're going to be using a singleton-like pattern here, and this provides global access to the event system so that all of the systems can subscribe and publish events. So essentially the quests and other game entities are going to be constructed incrementally. So building quests with requirements, rewards, and descriptions, we're going to try to incrementally build those. We have some structural patterns. So the Linen plugin, which is the Flax engine plugin, we're going to use that as a facade to access all these underlying complex systems. So that way, not only can you use a different engine if you want to, but it provides simplified access to the RPG subsystems. We're going to be using proxy, so that way we have like type safe stuff, and we're going to use like, get this system, and it's going to act as a proxy. That way we can handle systems retrieval, and we'll do type checking. We're using the composite pattern. So there's a hierarchical organization of RPG systems, and each system contains their own subsystems or components. The event system is going to be able to adapt to different event types to a common interface. This allows heterogeneous events to be handled uniformly. This is actually a key feature in this. We're going to use the bridge pattern, so we're trying to separate things out. So the separation between system interfaces and implementations of so you have like the system interface and you have the system implementation, and we want to separate those. And the abstract RPG system base class will have like concrete implementations, if that makes sense. We're doing a bunch of behavioral patterns. You can read these if you'd like. This video is getting kind of long, so I won't go over them all, but essentially we have an observer pattern, a command pattern. So a lot of these deal with the event system, so like the chain of responsibility, command, and observer patterns. We're using the strategy pattern for the dynamic loading and unloading. We have a large use of templates. So we have a base RPG system that defines the structure of initialization, shutdown, and updates. And so any derived system will implement these specific behaviors. We're using states. So I think everything in our RPG systems is essentially a state machine. So basically, we'll have system states during its initialization and its runtime. And so, for example, in the quests, we'll have, is this quest available? Is it active? Is it failed? Is it completed? Those sort of things. So, if I'm not mistaken, I think all of our systems can be implemented with a state machine or tree automata, whatever you would like to call it. Yeah, it's really cool. And it provides like raw performance because, well, we won't get into that yet. Visitor, I'm kind of using Visitor. The serialization mechanism where systems are going to visit different components. Basically, each system is implementing its own serialization logic, whether that be JSON or binary. We're using the mediator pattern. This is actually really cool. Like I said before, the Linen plugin itself is going to act as a mediator between the different systems, and it's going to manage how the systems discover and interact with each other. We're using concurrency, like I said, so we have the monitor and producer consumer patterns. Like our event publishing, the producers or systems that are publishing events are going to be hoping that a consumer or other system is going to be able to handle that event, and if it isn't going to be able to handle an event, it just kind of falls through and doesn't matter. Events are queued for processing, so that way we don't miss an event. And all the different architectural patterns. We have component-based architecture. The systems are modular and can be composed. This enables flexible system configurations. We have the event-driven architecture, like I talked about before, so that we can have loose coupling between the different systems. Systems will essentially be using dependency injection, so we're basically receiving references to the plugin itself and the other systems. So we'll set a plugin, so what plugin are you? I'm using this one. That way we can inject dependencies on some system, and so that way the system has all the different requirements available to it. Service locator, we're gonna locate dependencies, and each system will essentially locate other systems through the plugin itself. We have this layered architecture. So higher level systems are going to have to depend on lower level ones. So we have different phases or layers. So like the core systems and the world systems, and essentially the idea behind this layered architecture is that some systems will require other systems to exist before we can properly implement them. The publish and subscribe method pattern. So publishers don't need to know about their subscribers. Subscribers only need to know about who they're listening to. So that allows for a good, effective communication pattern. And then finally, we have a command query separation. So basically, methods either modify state or they return data, but they should rarely do both. They should rarely modify the state and return data. So we should try to achieve that. So basically, we have like query methods like get active quests, and also command methods like complete a quest. So like we should very rarely return data or modify state. So we should do one of two things, but not both. We should not get the active quests and complete a quest, for example, in the same method, if that makes sense. So yeah, that's kind of all of the different design choices and design patterns that that I've implemented in the pseudocode. So without further ado, I guess the next video will be working on getting this set up, taking our pseudocode that I've written and implementing it into a useful system.